Hey, Gary Parker here. Let's do some descriptive statistics analysis. So we are in week 2, almost finishing up chapter 2. Next week we'll finish chapter 2 with linear models. And we're looking at quantitative variables. And I need a spreadsheet to help me along. So let's see, the week 2 videos page has some spreadsheets at the bottom. Let's grab this one just for the heck of it. Alright, so this one already has some data in it, and then it has formulas for count, standard deviation, mean, min, all the basic calculations that we need to do. Cool. Alright, so then we need some data to go with it. I want to look at the nutrition studies. So from useful websites, I'm grabbing the dataset descriptions for the textbook datasets. And I am curious about this nutrition study, and in particular, fiber. Good for good bowel movements, right? All right, so we have 315 observations from 315 individuals, variables related to nutrition and health. And we have data from a cross-sectional study, so that means a variety of individuals, to investigate the relationship between personal characteristics and dietary fiber factors, and plasma concentrations, retinol, beta-carotene, other carotenoids. Study subjects were patients with elective surgery, so surgery they didn't have to biopsy something. This was done over a 3-year period. The lesions were removed from lung, colon, breast, skin, ovary, uterus, all sorts of places. So we got males, we got females. In here, this was American Journal of Epidemiology. Okay, so studying diseases. All right, so they are looking for characteristics of these individuals. So let's think about this sample, 315 individuals, were pulled from a population. What population were they pulled from? Well, given that this was the American Journal of Epidemiology, we've got humans in the U.S. When? In the late 1980s, okay. People then are pretty similar to people now. Yeah, so I'm going to say it's likely adults because we're talking about whether they smoked or not. It was an elective surgery. Kids with their parents could elect to have such a surgery. We do have age, so we can take a look at that. All right, so I'm assuming, right, the sample is clearly described right here, and there's 315 people, and I believe the population of interest is all U.S. adults. So that's the population. Got it. Next. Let's look at the data set. So age, and again, it's hard to get all those numbers all at once, right? So I'm looking at column B here. Let's pop that out into another sheet for fun. So I'm going to grab age, copy, new sheet, paste, and there's only a couple kinds of graphs that make sense with one quantitative variable. That's either a histogram or a box plot. Spreadsheets make shit box plots, so we're going to go for a histogram. So with the data selected, we're going to insert a chart and take a look at the distribution of values. Oh, okay, so we do have at least one teen in there. All right, so let's get some statistics on age, and then I'll take a look at fiber. So let's see, I'm going to call this tab age and fiber. So back to that other spreadsheet, I just want to grab these titles, labels, and formulas, copy them, and then paste them over here. And again, they have to be in the same location, so adjacent, because they are pulling from this column to the left. And that's the way spreadsheet formulas work. They work by relative location. If I had pasted this in a different spot, it would not have grabbed those numbers. For example, if I tried to paste it over here, I would get nothing. Okay, so min, 19. Okay, so adults. And again, first histogram, usually Excel and Google do a shit job, so let's fix that. those numbers on the bottom are not nice. We want nice numbers, so we're going to customize the histogram, and let's see if we go from 15 to 85. Let's try jumping by 5. Yeah, that's all right. Not too many, not too few. I'll take it. Histogram of age. That is a shit title. Let's make that better. Titles down here. Okay, so this is ages of people in nutrition study. And that is definitely age. What are these numbers? 10, 20, 30, 40? Well, that would mean there are almost 50 people between 40 and 45. So that's the number of people. So let's label that appropriately. Number of pupil. Oops, I not click there. Try it again. Number of pupil. All right, that's a good histogram. Nice. And again, there's no best histogram, so sometimes just for fun, once I get good titles in there, I will make a copy of it and make a slightly different one. Let's go edit, customize, histogram. Let's go by 10 this time, and let's start at 10. Okay, yeah, that's a nice histogram too, right? So we can see that one person in their teens, and then we have 20s, 30s, 40s, 50s, 60s, 70s, 80s. Notice that ends at 85. It's supposed to jump by 10, so we got to fix that with a 90. Okay, good. I have 2 nice histograms, well labeled. All right, now what I really wanted to do here was fiber, but I was curious about the ages. So I am going to duplicate this one. And then I'm going to replace, no, I'll just do it in the same one. Let's get rid of you. Let's add fiber over to the right. So let's scoot you over, and then get the fiber data and do same analysis. And then we got to look up what fiber means. Back here, paste. All right, and then, okay, what does fiber mean here? Fiber would be grams of fiber consumed per day. Okay, so we should label that better up here. Grams per day. I think age is pretty self-explanatory. Usually we do age for humans in years. All right, and then we just want to copy the summary statistics over, or the formulas is what we're copying. If you would notice, we'll get a whole new set of numbers here. Okay, mean fiber is 12.79 grams per day. Cool. All right, next we want some histograms for those. So copying the fiber data, and sometimes it works to highlight the whole column. Sometimes you got to go from the bottom to the top, top to the bottom. So let's go from the bottom to the top. Insert chart, and it picked a histogram for me, and it did a pretty good job, except it's a lame title. So let's customize and fix, and again, these numbers suck down there. Let's try 5 again. 5's a nice number. Yeah, we'll go with that. And give it a better title. Fiber grams per day for U.S. adults and nutrition study. Horizontal axis is labeled correctly. Vertical axis has no label. It's got to have a label. Number of whatever you're counting. We're counting people here. If you're counting dogs, you put number of dogs. These is people's. Okay. Done with that one. All right, so come on, move please. There you go. we can see there it is slightly skewed right. So what does that mean? It means there's a few people had an unusually large amount of fiber consumption compared to the rest. Skew is in the tail. And let's see, are there any outliers by the 95% rule, the 2 standard deviation rule, or the IQR rule? And 25 is the high, and there are definitely people above 25. So again, the skew of the graph and the IQR rule say, yeah, there's a few people that have an unusually high amount of fiber intake compared to the others. Notice the negative low, that means nobody has an unusually low amount of fiber. Although, that looks kind of low right there. For the IQR rule, we have a max of 23. Again, we have a bunch above that and a min of 2-ish for the rule, but in our actual sample, nobody had below 3.1 grams of fiber per day on average. So no one had an unusually low fiber intake by our outlier rules here. Okay, let's do another histogram. Duplicate, copy, that's what I want. And this time, edit, customize, histogram. Jumping by 10 will be too few columns. That'll be a shitty looking one, too blocky. So let's try jumping by 3. 3 is a nice number. That's okay, a little better breakdown. And again, 2, it might be too many columns. All right, those are my 2 histograms. I'm also going to take this over to another app to get a box plot. And then we'll talk more about the numbers. Copied, so I want useful websites. And ST243, I recommended that in the application for this week. Single quantitative variable, plop in the data, but the title can't go in there. The applet will freak out about it. Cut, paste, raw data, numbers, begin. All right, so it does a dot plot like StatKey does right away. Let's look at StatKey 2 for fun. StatKey, one quantitative variable, edit the data. Control A, delete, Control V. Oops, I forgot the numbers. Back here, copy, StatKey, paste, there we go. All right, so I don't have a first column identifying each number, so that unchecks, but I do have a title, so the header row stays. All right. And again, dot plot there versus the dot plot. Where'd you go? Here, right? Pretty darn similar. Histogram here. All right, similar to what I have in the spreadsheet. Histogram here. Ooh, that's a pretty one, right? Similar. They pick nicer numbers, so they do a better job than StatKey of picking nice numbers. Because again, StatKey, if we point to the column above 15, is really going from 13.2 to 16.6, and there's 68 items in there. If you look over to the right. All right, and then we're going to do the histogram with the box plot, and we're going to take a screenshot of that, stick it in my spreadsheet, and ultimately that will go in my document when I write up my analysis. And that looks lovely. Into the spreadsheet you go. Put you right there. Beautiful. All right. Next. Again, so I started talking about the analysis here. First thing is considering the distribution of data. So, ignoring the tail of, say, the 25, 30, 35, 40, relatively symmetric bell shape kind of in the middle here, right? We got that kind of bell shape going on. But we have a few people that have an unusually high amount. The box plot confirms, given that they're using the IQR rule to identify outliers. So instead of ending the whisker at the max, they're ending the whisker at 25.275, and then they're flagging any values in the data set with points to indicate they're unusually high compared to the rest. So we don't just say the data has outliers, we say, in this case, there are several individuals who have an unusually high, in this case, fiber intake compared to the rest. We can see that most people's fiber intake is between 5 and 20 grams per day. The box plot, if we look at the numbers in the box plot, for example, if we look at Q1 through Q3, right, that's the box, that's 50%. So 50% of people in this study had a fiber intake between 9 grams and 15 grams. Right, so that's another observation we can make about this. The mean is a touch higher than the median, and that usually happens with a right skew. These numbers that are further to the right from the center make the mean a little higher than the median because we use those numbers to calculate the mean. The median is just whatever number's in the middle. It doesn't care how far away the higher or lower numbers are from center. So the mean and standard deviation are subject to movement based on extreme values, whereas the median and the IQR are not. They're just in the middle. All right, what else can I say about this? Standard deviation. Let's check the coefficient of variation, which is to take the standard deviation, divide by the mean, and make it a percentage. So our percent spread from the mean is about 40%. So that's just another way to talk about the spread of the data. So the variation in terms of spread, we have standard deviation as a measure of that. Coefficient of variation is another related measure. The IQR, which is the width of the box, the distance from Q1 to Q3, so that's that 6.45 down here. I didn't put the range in here. Let's put the range in here. Range is the distance from the max to the min. So let's take the max, subtract the min. And again, those are all, measures of variation spread. Measures of center are our mean and our median. And I hope in your homework you're using a spreadsheet like this to do some of the calculations. We never, ever do standard deviation by hand. That's foolishness. Use a calculator like a spreadsheet or StatKey or StatApplet. Similarly, quartiles are a pain to do without a calculator. We should use technology to do those, especially given large data sets. Things that are easy to do by hand are, say, the 95% rule to calculate outliers or the IQR rule to calculate outliers. Those are easy to do by hand once we have all the other calculations. But this group of calculations here, we should use a spreadsheet or something like StatKey to do it. Right, those are the basic statistics we need a computer for. Otherwise, we can do the rest by hand. All right, hope this was helpful. Stay in touch. Do good math. I will see you in the near future. Adios.